Welcome, beginner game developers, to this comprehensive guide on combining your skills to create an engaging mini-game using Unity 3D and Visual Studio. This tutorial will walk you through every step, from setting up your development environment to building a functional mini-game, complete with helpful tips along the way. First, let's ensure you have the necessary software installed. Unity 3D is a powerful cross-platform game engine for both 2D and 3D games. Visual Studio, an integrated development environment, is essential for writing, editing, and debugging your game's code. Begin by downloading and installing the latest versions of both Unity 3D and Visual Studio from their respective official websites. During the Visual Studio installation, remember to select the Game Development with C++ workload to include all essential tools and libraries for Unity integration. Unity Hub is crucial for managing different Unity versions and all your game projects efficiently. Now, let's create a new project in Unity. Launch Unity Hub and click the New Project button to begin. For this tutorial, we will choose a 3D core template, which provides a basic setup for three-dimensional game development. Name your project, for example, Minigame Tutorial, and select a suitable save location on your computer. After naming and locating your project, click Create to generate your new Unity project. Once the project loads, you can customize the layout by arranging windows like Scene, Game, Hierarchy, Project, and Inspector to suit your workflow. Default layouts are also accessible under the Layout drop-down menu for quick configuration. Let's understand the Unity interface. The Scene view is where you visually build your game by adding and manipulating objects. The Game view allows you to preview your game from the player's perspective, showing exactly what the player will see. The Hierarchy window lists all objects present in the current scene, providing an organized overview. The Project window displays all assets, including scripts, materials, and scenes that are part of your project. Finally, the Inspector window shows the properties and components of a selected game object, allowing for detailed adjustments. Now, let's dive into basic game development steps. You can add basic shapes like cubes, spheres, and planes to your scene via GameObject Create. Every game object possesses a transform component, which defines its position, rotation, and scale within the game world. Materials are used to change the appearance of game objects, defining their color, texture, and other visual properties. For dynamic behavior, we use C# scripting to control object movement and game logic. Our minigame objective will be a dodging game where a player avoids falling obstacles. We'll create a sphere as our player and cubes as the obstacles. A rigid body component makes game objects subject to physics, allowing them to react to forces like gravity. Colliders are essential for detecting interactions between game objects, such as when our player hits an obstacle. Let's begin by creating a new Unity project. Open Unity Hub and click New Project. Choose the 3D core template, name your project Minigame Tutorial, and select a location, then click Create. Next, set up the scene. Create a ground plane by navigating to GameObject 3D Object Plane. Create a player sphere using GameObject 3D Object Sphere and position it above the ground. Then, create a cube as an obstacle via GameObject 3D Object Cube and place it off to the side for now. Adjust the main camera's position to get a good view of your scene by selecting Main Camera in the hierarchy and modifying its transform in the inspector. Now, let's create the player movement script. In the project window, right-click, then create C# script and name it Player Controller. Double-click the Player Controller script to open it in Visual Studio. Add the following C# code to define player movement and collision detection. This script includes a public speed variable, a rigid body reference, and start and fixed update functions. The fixed update function handles physics-based movement using input from the horizontal and vertical axis. The onCollisionEnter method detects collisions and destroys the player object if it hits an object-tagged obstacle. Save the script in Visual Studio and return to Unity. Attach the Player Controller script to your player sphere by dragging it from the project window to the inspector. Adjust the speed value in the inspector to control how fast your player moves. Add a rigid body component to the player sphere by clicking Add Component in the inspector and searching for rigid body. Next, we'll create the obstacle movement script. Create a new C# script in the project window and name it Obstacle Movement. Open Obstacle Movement in Visual Studio and add the following code. This script defines a move speed and uses the update function to make the obstacle move downwards. It also destroys the obstacle if its Y position falls below -5, ensuring old obstacles are removed. Save the Obstacle Movement script and return to Unity. Attach the Obstacle Movement script to your cube obstacle by dragging it from the project window to the inspector. Adjust the move speed value in the inspector to control how fast the obstacles fall. Add a rigid body component to the cube and check is kinematic to prevent it from being affected by physics forces like gravity. Crucially, add the tag obstacle to the cube in the inspector. This tag is used for collision detection in the player script. Now, let's create an obstacle spawner. Create an empty GameObject by going to GameObject, create empty, and name it Spawner. Create a new C# script named Spawner in the project window. Open this Spawner script in Visual Studio and add the following code. This script includes an obstacle prefab reference and a spawn rate variable. The start function uses invoke repeating to call spawn obstacle at a set interval. The spawn obstacle function instantiates the obstacle prefab at a random X position at the top of the screen. Save the spawner script and return to Unity. Attach the spawner script to your spawner GameObject by dragging it from the project window to the inspector. Drag your cube obstacle from the hierarchy into the project window to create a prefab. Then drag this new prefab to the obstacle prefab slot in the spawner script component. Adjust this spawn rate value in the inspector to control how frequently obstacles appear. Finally, it's time to test your game. Press the play button in the Unity editor. Move the sphere using the arrow keys and try to avoid the falling cubes. Congratulations, you've just created a simple mini-game. Here are some helpful tips to enhance your game development journey. Always use comments in your code to explain what each section does, making it easier to understand and maintain. Keep your project organized by creating dedicated folders for scripts, materials, and other assets. Utilize prefabs for game objects you want to instantiate multiple times, like our obstacles, to save time and ensure consistency. Use debug, log in your scripts to print values, and check if your code is working as expected during runtime. Explore Unity Learn, which offers guided learning experiences and tutorials for various aspects of game development. Leverage Visual Studio with its dedicated Unity workload for enhanced productivity features, including intelligent code completion and debugging tools. Remember, game development is an iterative process. Don't be afraid to experiment and refine your ideas. Practice regularly, and you'll continuously improve your skills in creating engaging and fun games. We hope this step-by-step guide has provided a solid foundation for your mini-game development journey. Keep exploring, keep creating, and enjoy the rewarding process of bringing your game ideas to life.